You can make only 4 different cuboids with 16 cubes. Which cuboid has the largest volume? Tick the correct answer below. Is it cuboid A, B, C, D, or all the same? Explain how you know. So we can see that they've used 16 cubes in all of their cuboids. So that means that they all have the same volume. We know that because they all have a volume of 16 cubes. Volume is how much space a 3D shape takes up, and all of these cuboids take up the same amount of space because they're all made using 16 cubes. Now, how many of cuboid D make a cube of dimensions 4 by 4 by 4? Well, if we look at cuboid D, we can see that we have a length of 4 on this side. So to make a length of 4 on this side here, we'd need another of cuboid D next to it. So we'd need 2 of cuboid D at the base or at the bottom, but then to get a height of 4, we'd need another of those cuboids on top of each of our cuboids. So we'd need another cuboid next to it and then 2 on top. So that would be 4 of cuboid D altogether. Notice 4 times 4 is 16, times 4 is 64. And 16 times 4 is 64, so that's another way of working out that we'd need 4 times the number of cuboids to make a cuboid that's 4 by 4 by 4. Alfie and his brother walked from home to their school. Their school is 2 kilometers from home. The graph shows information about Alfie's journey. How does the graph show that Alfie walked at a constant speed for all of his journey? So a constant speed means a speed that stays the same, so not speeding up or slowing down, but staying the same. And the graph shows this because the graph is a straight line. If it was sloping upwards or curving up, then Alfie would be getting faster, and if the curve was flattening, Alfie would be slowing down. But because it's a straight line, that shows that he walks at a constant speed. Now, Alfie's brother left home 10 minutes before Alfie. He arrived at school 20 minutes after Alfie. He walked at a constant speed for all of his journey. At what time did Alfie overtake his brother? So he left home 10 minutes before, so 10 minutes before 8 o'clock is 7:50, and he arrived at school 20 minutes after. So 20 minutes after 8:30 is 8:50. So because he walked at a constant speed, we can join these points with a straight line, and then where the 2 lines overlap will be where Alfie overtook his brother. So we can see that that's at 8:10. Write the correct sign, less than, equal to, or greater than, in each box to make these sentences correct. So first, we have 3/10 and 10/3. Now 10/3 is an improper fraction because it has a larger numerator than denominator, and improper fractions are always greater than 1 whole. So we know straight away that 10/3 will be greater than 3/10 because 3/10 is less than 1 whole. So now we have 6/5 and 8/7. Now we could compare these fractions by making our denominators the same. So 35 is in both the 5 and 7 times tables. So we could find equivalent fractions with a denominator of 35. But sometimes, if you've got improper fractions, it's easier to compare them by first converting them into mixed numbers. So 6/5 is the same as 1 and 1/5 because the denominator stays the same, and 6 divided by 5 is 1 remainder 1. And 8/7 is the same as 1 and 1/7. 8 divided by 7 is 1 remainder 1. So now we can compare these because we know that the larger the denominator, the smaller the fraction, because that means the whole has been divided into more pieces. And because our whole number and our numerator are the same for both numbers, we can compare these just by looking at the denominator. So that means 1 and 1/5 is greater than 1 and 1/7, so 6/5 greater than 8/7, because the smaller the denominator, the larger the fraction will be. And now we have 39 over 27 and 26 over 18. So it would be hard to compare these in the usual way that we do this, which is to make the denominators the same, because we would need a number that's in the 27 and the 18 times tables. Now we could find that number, but sometimes it's easier first to change to a mixed number and then to simplify. So 39 over 27 is the same as 1 and 12 over 27, and 26 over 18 the same as 1 and 8 over 18, because 1 times 18 is 18 plus 8 is 26. So now, because the whole number is the same, we can compare 12 over 27 and 8 over 18. But sometimes it's easier to simplify the fractions first. Otherwise, like I said, we would need a number that's in both the 27 and 18 times tables. So we can simplify 12 over 27 because both the numerator and the denominator are multiples of 3. So if we divide both by 3, that gives us 4/9. And we can simplify 8 over 18 because those numbers are both in the 2 times table. And if we divide both by 2, that gives us 4/9 as well. So both of these fractions are equivalent to 1 and 4/9, so they're fractions of the same value. They're equivalent, so we need an equal sign. The diagram shows a cuboid. What is the volume of this cuboid? So we calculate the volume of a cuboid by multiplying the length by the breadth by the height. And because they've given us the dimensions, to find the volume, we just need to multiply 10, 10 and 6. So 10 times 10 is 100, times 6 is 600, so the volume is 600 centimeters cubed. Now, the volume of a different cuboid is half the volume of the cuboid in part A. What could the dimensions of this different cuboid be? So in part A, we had a volume of 600 centimeters cubed, and half of that is 300. So we need to think what times what is 300. Well, we could have 10 times 10, so that's 100, times 3 is 300. So notice, to halve the volume, we only need to halve one length, and we can leave the other two lengths the same. We could also have a volume of 300 if we had 10 times 6, so that's 60 times 5. So if one length is halved, volume is halved. If you know 40% of a number, explain how you could work out the original number. So the original number will be 100% of the number. So if we know 40%, we could divide by 40 to get 1%, then multiply by 100 to get 100%. So if we have 40%, that's 40 hundredths of our total. So here we have a section divided into 100 pieces, and what's coloured in blue is 40% because that's 40 of those pieces. So we can divide by 40 and that would give us 1%, and then multiplying by 100 gives us 100% of our total, so that's our original number. The other thing that we could do is divide by 4 to get 10%, then multiply by 10 to get 100%. So if we have 40%, that's the same as having 10% 4 times. So if we divide by 4, that will give us 10%, and then because there are 10 10%s in 100%, we can multiply that by 10 to get 100%. The diagram shows a square of side length 12 centimeters. Inside the square are 8 congruent trapeziums and a shaded square. The side length of the shaded square is 6 centimeters. What is the area of one of the trapeziums? So the area is how much space a shape takes up. So to find the area of one of these trapeziums, what we can do is find the area of the larger square, then subtract the area of the shaded square, and that will give us the area of 8 trapeziums. And if we know the area of 8 trapeziums, we can find the area of 1 by dividing by 8. So to find the area of the larger square, we can multiply 12 by 12, so that gives us 144 centimeters squared. And we know that the side length of the shaded square is 6 centimeters. So we can multiply 6 by 6, and that gives us 36. So if we want to know the area of 8 of our trapeziums, we can subtract the area of the shaded square from the area of the larger square, and 144 minus 36 is 108. So that tells us that these 8 trapeziums have a total area of 108 centimeters squared, because then if the shaded square is 36, 108 plus 36 gives us a total area inside the larger square of 144. So because we know the area of 8 trapeziums, and we know that the trapeziums are congruent, which means they're all the same size and shape, we can find the area of 1 by dividing the total area by 8. 10 divided by 8 is 1 remainder 2. 28 divided by 8 is 3 remainder 4. So we can extend with a point 0, copy up our decimal point, and then write the remainder 4 in front of our tenths digit. So 40 divided by 8 is 5, which means that one trapezium has an area of 13.5 or 13.5 centimeters squared.